Hello guys, welcome back to my YouTube channel. So today we are going to solve weekly contest 418 problem question number 2. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's read the problem statement first. You are maintaining a project that has n methods numbered from 0 to n minus 1. So see here, n is equal to 4. That is why you are seeing these methods 0 to 3, right? N minus 1, right? So 0, 1, 2 and 3. Okay, you are given two integers n and k and a 2D integer array invocations where invocations of I, ai, bi indicates that the method a of I invokes method b of I. Okay, so 1 2 simply means that 1 is invoking method 2. That's why you are seeing arrow like this. 0 1 simply means 0 is invoking method 1. 3 2 simply means that 3 is invoking method 2. Okay, that is why you are seeing arrows like this. There is a known bug in method k. Okay, so k is 1, so means that at one method there is one bug. Okay, so method k along with any method invoked by it, either directly or indirectly, are considered suspicious and we aim to remove them. Okay, one is suspicious, so I am going to write S here, mark it as suspicious. One is invoking this 2, mark it as suspicious. This 2 is invoking 3, no, this 3 is invoking 2 here. Okay, this 1 is invoking 0, no, 0 is invoking 1. Okay, so only these two methods are suspicious along with any method invoked by it directly or indirectly are considered suspicious and we aim to remove them. Okay, so can I remove this 1 and 2? Okay, let's read the further statement first. A group of methods can only be removed if no method outside the group invokes any method within it. Okay, so see here, this is non-suspicious method, right? And this is also one non-suspicious method, right? This 0 is invoking this suspicious method which makes it non-suspicious. Okay, this one which is suspicious is invoked by a non-suspicious method which is going to make this one as non-suspicious, and definitely then this is also going to become non-suspicious, right? This, see here, method 2 and 1 are suspicious but they are directly invoked by methods 3 and 0 which are not suspicious. We return all the elements without removing anything. That is why you are seeing this output 0 1 2 3. Okay, return an array containing all the remaining elements after removing all the suspicious methods. You may return the answer in any order. If it is not possible to return all the suspicious methods, none should be removed. But I hope that you guys are clear with what we need to do here. Okay, so simply means that we are going to create simple graphs and all that stuff. We are going to keep track of suspicious and non-suspicious methods. Okay, so you can pause this video and try to code it. Okay, so simple, do one thing. You know this n k value and the invocation, so just create one graph using this. Okay, link this 0 with 1, 1 with 2 and this 3 with 2. Okay, then create one array, suspicious array, let's name it suspicious. Okay, in a name, give this 0 as non-suspicious, 1 as suspicious. Initially this 2 is suspicious, 3 is non-suspicious. Okay, then just use simple dfs. Okay, because using dfs we can mark this as suspicious now, because this 2 is invoked by 1. Okay, so we are using this now, 1 to 2 we are moving, then after that 2 we are searching if there is anything. Okay, simply we are using dfs to mark them as suspicious, non-suspicious. Okay, and after that just see if this suspicious method is invoked by any non-suspicious. If it is invoked by non-suspicious, then definitely we are going to make it as non-suspicious. Simple. Okay, so now I'm going to move to the coding part. Okay, so I have added all the comments for better understanding. Okay, so see here, first thing that I'm doing here, I'm going to build the graph and the reverse graph. Okay, if needed. Okay, so first let's build the graph. Okay, so here this is nothing but list of integers. Okay, like this. Okay, list of integers, then I am iterating over all the elements one by one. Okay, I is equal to 0, I is less than n. Okay, and I am creating the graphs. Okay, so here 0 1 2 3. Okay, so here n is equal to 4 now, so here I'm taking 0 1 2 3. Okay, so I'm considering example number 1. Okay, so for this I have created one array list. For this I have created one array list. For this I have created one array list here. For this I have created one array list here. Then what I'm doing, I'm going to fill the graph with invocations. So I am going to iterate over all the invocations I have. So a of I first element, b of I second element, and a of I to b of I there is one link, right? So here see, one is invoking this 2, one is invoking 2, so here I'm writing 2. Okay, 0 is invoking 1, so here I'm going to write 1. Okay, and 3 is invoking 2, so here I'm adding 2. Okay, so this is how my graph is going to look like after feeding all these values. So I hope that you guys clear until now. Okay, then I'm going to use DFS to find all the suspicious methods directly or indirectly invoked by it. But from here you guys are clear, right? 0 is invoking 1, so 0 is invoking 1, 1 is invoking 2. Okay, 1 is invoking 2, 1 is invoking 2, or 1 is invoking 2. Okay, yes, so 1 is invoking 2, and 3 is invoking 2, 3 is invoking 2. Okay, 3 here. Okay, so this is the case. Okay, I have created the graph like this. All right, then use DFS to find all the suspicious methods directly or indirectly invoked by K. So I am creating this boolean suspicious array of length n. Then I am calling this method DFS mark suspicious graph, passing the graph, this is a graph that I have, right? Passing the graph K value, okay, and suspicious. Okay, so now see this, how I'm doing this. Private void DFS mark suspicious, I am passing the list of integer graph, I'm passing graph node and this. So I am making this suspicious of node, so node is nothing but this K value. So K is 1 here, right? So suspicious of 1, I am marking this as true. Okay, so this is suspicious. Then I am checking the neighbors of this one. So here neighbor is equal to graph.get node. So graph.get this particular node 1. So I will see this is not suspicious right now. Then I'm going to mark this as suspicious. So I'm going to mark this true, this to true. Then I'm going to check the neighbor of this one. So there is no thing that is invoked by this 2, so that's it. So this is how using DFS I am feeding my marking the method as suspicious or non-suspicious. Okay, so this is done. Step 3 is check if any external. Okay, so we are done with this. Use DFS to find all the suspicious method. Okay, this is done. Now we move to step number 3. Okay, so now we are going to check if any external method invokes a suspicious method. If any non-suspicious method invokes a suspicious method, we cannot remove them, right? So here I am just going to iterate over all these numbers one by one, methods one by one. Okay, I am going to check if it is non-suspicious. Okay, so 0 is non-suspicious, right? I'm starting from here. So if 0 is not suspicious, I'm going to check for the neighbors of this 0. So 0's neighbor is 1. Okay, I'm checking neighbors. Check for external invocation from non-suspicious method. Okay, so this is a suspicious. So here I'm checking this condition. If this is suspicious, if this neighbor is suspicious. So if this is suspicious, then what I'm doing, I'm external method I invokes a suspicious method, removal is not possible. I am creating one all methods list, right? And then I am running this j from 0 to n minus 1. I am adding all the numbers in my all methods, and I am returning all the methods, right? This is done, right? That's it. Okay, so this is going to make this as false. Okay, and this is also going to make this as false. Okay, because after that I will iterate over 1, and for 1 also I'm going to add like that only, right? So this is done. Okay, and after that here's the step 4. We are just going to collect and return the remaining methods, non-suspicious methods. Okay, so what we are going to do here, list of integer remaining, new array list we are going to create, and then we are again iterating over all the elements again one by one, and we are checking if not suspicious. Okay, if it is not suspicious, we are going to add that into remaining and return remaining. That's it, that's it. Okay, so here in this step 3, I'm just going to check if any external method invokes a suspicious method. If any non-suspicious method invokes a suspicious method, we cannot remove them. Okay, so this is what we need to do here. Okay, so we are iterating over all the neighbors one by one. Okay, and we will see if any method, okay, if any method. Okay, so here I is equal to 0, so at 0 only I will find that this is not suspicious. Okay, so if this is not suspicious, then after that inside this, okay, I'm checking the neighbors, and for inside this I'm going to check if this is suspicious. Okay, then after that if it's suspicious, then we have to just add all the elements, right? Because we are making them as non-suspicious because they are invoked by one non-suspicious method. Okay, so this solution is accepted, right? So I hope that you guys are able to understand this problem. Question number 2, please like this video, share this video with your friends, and don't forget to subscribe my YouTube channel. Meet you guys in the next video. Thank you. Bye bye.